Hello, good evening. I'm Michelle Carter, Director of the Aaron Public Library, and tonight we have the wonderful presence of Wayne Ozzie Osborn. Wayne comes to us, he's presenting Pluto, Planet or Not. Ozzie is a native of California who developed an interest in astronomy in middle school. He attended the University of Berkeley and pursued graduate studies, excuse me, at the University of Maryland, Wesleyan University in Connecticut, and Yale University to complete his PhD. So I turn the presentation to you, Ozzie, and thank you for doing this event for us today.
Well, I enjoy these things very much, and we'll see if the visitors to our virtual presentation will enjoy it too. This is part of the Aaron Library's sessions on astronomy that they're running right now this month. And we had planned to do an outside viewing session, but the weather has not cooperated very well. We've had very cold weather here, including wind chills down to -20 or 30 even one night. And we're not sure that outside viewing would be safe and convenient for people. So we'll do that later, maybe in the summer. But we're going to talk about the planet Pluto tonight. The planet Pluto was discovered in 1930, actually in February 18th. And Pluto was quite an exciting thing at that time because it was a new planet that had been looked for a long time and then discovered. And then about 20 years ago, the astronomers got together and said, well, it's not really a planet. So we're going to talk about why that occurred, why astronomers made that decision. So Pluto, planet or not. And I think you can see my cursor if you are watching the screen. You see Pluto, but we're not talking about Pluto like that. We're talking about Pluto, a body in the sky. Now, minimize that a little bit. The discovery of Pluto is a sort of an interesting story. All the way back to ancient times, people have followed the sky and looked at the sky. Of course, that was naked eye astronomy. And it wasn't too long before people found that there are 7 what they call special bodies in the sky. Those are the sun, the moon, Mercury, Venus, Mars, Jupiter, and Saturn. And why they're special is because they move, they change their positions amongst the other things. So if you go out in the summertime, you see different stars than you see in the wintertime. And you might see Venus in the summertime, or you might see it in the wintertime. It would have different positions depending on where it is in its orbit. So these became special bodies. In fact, so special that in many cases they were called gods. And they form the basis of our weekly calendar. We have Sunday and we have Moon Day. And the other days of the week are actually named after these 7 bodies. Today we classify these bodies by the sun being a special one. It is a star, just like the other stars we see in the sky, but it happens to be particularly close to us. It's so close that its brightness blocks out the other stars when the sun is up in the sky. The moon, of course, we know orbits around the Earth. It's a satellite or a moon of our planet. And then the other ones that we see in the sky are what we classify as the 5 naked eye planets: Mercury, Venus, Mars, Jupiter, and Saturn. And I listed them in that order because that's the distance they are from the sun, but also how fast they change their positions in the sky. Oops, let's see if I can get my screen to go ahead. Oh. There we go. So in 1781, there was an astronomer named William Herschel. He was actually a musician. He was the musician for the King of England, even though he was German. And he liked to do astronomy with a little telescope. And he discovered a body that he thought was a comet. It was moving, but it had no tail. When we say moving, that means it changes its position from one night to another, not that you see it actually move in the sky. But if you go back and say, oh, it's not exactly next to that star, it's moved over a little bit. Those things that they discovered that were moving besides the regular planets were comets usually, but this one was a strange one. It had no tail. And when they actually calculated its orbit, there was a huge surprise. The orbit showed that it was a new planet. No one had thought up to that time you would have other planets besides the naked eye planets in our solar system. This, of course, was a very exciting event and created a number of controversies. First of all, what do you call it? Now, William Herschel, who was working for the King of England, who was King George, same King George that the American colonists were having problems with, he said, we're going to call it George's planet. Now, the French and other countries didn't quite like that. There was an argument. They finally decided they would call it the planet Uranus after another one of those mythological gods. Another thing that was done was they went back to see if there were any older observations. And sure enough, they were able to find that some of the star charts that had been made listing the stars, the astronomers had seen the planet Uranus in its orbit. And that's good because once you get a long number of observations covering, 20 or 30 years or more, then you can get a good orbit for it. And yes, they found the older objects and they found that it was in what we call a perturbed orbit. That means the orbits seem to be not quite regular, but there was some gravitational force on it that was not understood. People quite soon said that's probably another planet farther out. Just like we didn't expect to find Uranus, there was a planet that could be looked for farther out that was affecting Uranus in its orbit. And that led to the discovery of Neptune. 1844 to 1846, I put in there several years. It actually was found in 1846, but it's an interesting case because the planet Uranus was not following the orbit that it should unless there was some body attracting it. So there was actually a student in England by the name of Adams, and as a student project, he decided to calculate where this planet should be based on the gravitational pull on Uranus. And he made his prediction, and then he went down to the observatory in England, the Royal Greenwich Observatory, and asked the astronomer there to go and look for it. And of course, the astronomer said, well, you're just a student. I'm not really sure that a student could calculate a very accurate position. It's not worth our time. So they gave him a mathematical thing and said, if you can pass this mathematics test, then maybe we'll go look for it. At the same time, there was a Frenchman named Leverrier who in France had predicted a position. And as soon as he had his prediction, he asked the Paris Observatory to go look for it, but it was cloudy. So they sent a telegram to the German observatory, and a German astronomer in Gale found it just about at the position the French had predicted. Now, it turned out that was pretty close to the position Adams had predicted. Right? Once again, there was a bit of a controversy because the English said that, well, really Adams had predicted it. It's just they didn't have time to look for it. Actually, they didn't want to look for it. The French said, we discovered it. The English said, no, we really predicted it and knew where it was. So who discovered it? Who gets credit for this? Is it the German? Is it the French guy? Or is it Adams, the English guy? And who gets to name it? Well, the names they decided should be the mythological names. It got the name Neptune. So what do you do when you find a new planet? The same thing they did with Uranus. They said, are there any older observations? And they went back and looked through the records. And it's very interesting. They found a number of older observations, but very surprisingly, they found that the first person ever to use a telescope, Galileo, had actually apparently spotted this object. He made a chart. It showed the planet Jupiter, but there was a star in the background. And there goes my thing. There we go. This is actually from Galileo's notebook. And he's got these stars labeled out here. And he says in his notes, if you can read the Italian, which I can't very well, he says, it looks like this star's moved. And sure enough, star B is the one. Here's a star over here he saw, and here's the star over here, and this one looks like it's moved. This is Jupiter that he was trying to observe. So Galileo really had observed this planet and then recognized that it was a new planet. He did detect the motion, but didn't follow up on it. And what this tells us is that because things change slowly in astronomy and you don't know what's going to happen, it's very important to take notes. This was from 1613. And of course, the Neptune was not really discovered until the 1840s. Okay, well, you can do the same trick, can't you? You get Neptune's orbit and you look to see if it looks like it's being perturbed, if it's following a nice orbit, if there's something gravitationally pulling it farther out. And there was some indication that there might be a more distant planet. It was called Planet X. And a number of astronomers tried to predict where this planet would be. Now, its gravitational pull was very weak, so it was hard to make the calculations as to where it would be. Two people really participated in. One was named Lowell, who actually set up an observatory called Lowell Observatory. It still exists in Arizona. And Pickering, who was a Harvard astronomer. And they both began searching based on the perturbations of mainly Uranus, but also a little bit Neptune. They didn't have as long an orbit of Neptune for this Planet X. And in 1930, Planet X was found, apparently found, and then it was confirmed later at Lowell Observatory that Percival Lowell had set up. And after the announcement, once again, there was discussion who gets to name it. So the actual discoverer, whose name was Tombaugh, said, well, why don't we just put it out there and see what people suggest? And the name Pluto was suggested by an English schoolgirl. And they accepted that because Pluto is a god that was in the outer, sort of the darker part of the Greek universe, and that's where Pluto is. And not only that, the symbol that was adopted for Pluto is PL, which is Percival Lowell of Lowell Observatory. His initials form the symbol we use for that planet. So it was pretty appropriate to call it Pluto. Now, here's the discovery picture, actually. January. Now, it wasn't announced until February. And that's because, as we're going to see in a minute, they took photographs, but they had to look at the photographs, and it took them about a month to look at the photograph in enough detail to discover it. If you look at these two stars that you can see here in the sort of the center, the bright ones. Whoop, I want to go back. The off to the side in the circles, you'll see that there's a body that appears in the January 23rd photograph, and by the January 29th, when it's moved past those two bright stars over toward the right in our picture. Now it's really faint, you notice it's not very visible. It was particularly faint. They thought it would be much brighter, and that's one of the reasons it was not discovered for many years. Well, when you find a new planet, you see if there's any older observations. Pluto is too faint to be on any drawings or records of that type, but you might find it on older photographs. So they looked for its approximate position, and they did find 14 photographs that were taken at different observatories. And surprisingly, for Wisconsin, the earliest one that's been identified is Pluto was seen at Yerkes Observatory in 1909. It's more than 20 years prior to when it was discovered. And having these early observations then allowed the orbit to be computed, because it moved so slowly that on just a few observations, you could not tell what the orbit was like at all. You could just make a little prediction as to where it would be the next night or maybe the next month, but you couldn't go much farther back or forward than that unless you really worked. So, here's the Pluto discovery photograph. And I think you'll agree that it's pretty hard to pick out Pluto amongst all of those stars. Every black dot, this is a negative photograph, so every black dot is a star on this. And up in the corner of the photograph, you can see that there's some numbers. That's the plate number that was taken at Yerkes Observatory and the time. And actually the envelope that has this plate, and I've looked at this at the Yerkes Observatory collection, has marked on it Pluto. And if your little marks here, that is where Pluto is. The astronomers were able to track it down by looking at objects that had moved from one photograph to another. If we zoom in on that, here is that little set of stars here with Pluto in it. They used these little things right here indicate this star was used, this star was used, and this star was used to calculate its position. And the two dots indicate there's something unusual between those two, and that little red arrow points to what Pluto looks like. Pretty faint, pretty hard to find. Here's the 1909 photograph. It's different, it's even fainter. You can barely see a smudge there, but it is there. So Pluto actually had been observed for about 20 years by photographs before it was actually found. Very difficult to pick it out because it's in a very rich star field. Okay, now that you've got the old observations, you can calculate the orbit. And what did they find? It's a strange orbit. Here you see the orbits of the planets. I think you can see the comet Halley, which is a very elongated orbit, but Pluto has such an elliptical orbit that it actually comes inside the planet Neptune for a while. It's not nice and circular like all of the other orbits of the planets. Something was strange about this. Not only that, the orbit's very tipped. Compared to all of the other planets, it has a tilt of about 20 degrees, 27 degrees. That makes it very unusual. It didn't seem to fit what we knew about planets in the solar system to that time. And later, when it was able to be observed more carefully, they found that Pluto was very small, much smaller than our moon. Smaller than all the other planets, of course, but smaller than even many of the moons in our solar system. Here you see a picture that shows the Earth with the moon to the left up above and Pluto right below it. So you can see it's a pretty small, quote, planet. And if you look at the size of it, it turns out that it doesn't have enough mass, it didn't have enough gravity to affect the other planets. So really the discovery of Pluto was by chance. They had predicted based on poor data where they thought it would be, and they actually found something there. But now that they know about its orbit and about its size, there really wasn't enough gravity there to be affecting Uranus and Neptune, which leads to the question, are there other planets farther out? We'll get to that maybe in a little bit. Okay, so that's Pluto, the discovery of Pluto. Pluto was called a planet, but this begs the question, we need a definition of what a planet is. If you ask people what a planet is, they'll probably say, well, it's a body that goes around the sun. And then you can say, well, comets go around the sun. Well, they're not, they aren't really planets because they have tails. Well, what about asteroids? They go around the sun. Well, they're too small. Here's an example. The first asteroid discovered was called Ceres. It was discovered in 1801, and people said, oh, we found a new planet. And then, not too many months later, they found another one, and then two more by 1807. They found between 1801 and 1807, 4 of these real small planets. By 1850, 13 of them were known. They were all small. They all had pretty similar orbits. They all orbit between Mars and Jupiter. And the astronomers said, well, these aren't really planets. When you start getting, lots of these things, they aren't new planets like the planets we know. So they said they're a new type of thing. We now call them asteroids or minor planets. So we had to rethink our definition of what a planet is. A planet has to be big enough and have certain characteristics to be a planet. Astronomers soon turned to what they call defining a planet by its physical properties. That means what it's made out of, what its size is, whether it has an atmosphere, whether it has moons or not. And if you use that physical classification, it turns out that we have several types of planets and other bodies in our solar system. We have four, what we call the gas giant planets: Jupiter, Saturn, Uranus, and Neptune. They're composed almost entirely of hydrogen with some helium, but they don't have really solid surfaces such as we have on the Earth and on Mars. These are big planets, much bigger than the Earth, and they're primarily gaseous. We say hydrogen and helium, but actually, because of the high pressures, the interiors of these bodies are mostly liquid, particularly Uranus and Neptune. They're primarily liquid planets. We have 9 rocky planets. We have the Earth, Mars, Venus, and Mercury, but also our moon is big enough to be considered sort of a planet if you use the size of it and what it's made out of. These are made out of rocky material. They have solid surfaces. You can walk around on these, and we've seen pictures of people in the old space missions walking on the moon, cars driving on the moon. 2 of the moons of Jupiter are large enough that you could do that, and there's other moons that also, some of them have even little atmospheres. Some of them have volcanoes. So we have a number of these planets on our definition of what a planet is that are Earth-like planets, as we call them, or rocky planets. And some of those we're starting to explore by spacecraft. Then we have smaller bodies that are primarily made out of ice. Many of the moons in the outer part of the solar system are small. Some of the asteroids are like that, mostly ice, and Pluto turns out to be mostly made out of ice. And then we have small bodies that are mostly rocky material. These are the asteroids that we tend to think of, and some of the very small moons. And even meteors are typically rocky material, sometimes icy, but mostly rocky material. So what is a planet has to be defined, and we define them by what their characteristics are, their physical characteristics, how big they are, whether they have atmospheres, whether they have moons. So part 3, with big telescopes that they started to put into operation in the 1990s, they surveyed the outer part of the solar system. Of course, they wanted to look for that mysterious planet farther out than Pluto. And what they found is that there's many, many objects about at Kuiper's distance. There's another asteroid belt out there beyond. If you look at the picture over here, you'll see Uranus and Neptune. Out beyond where Pluto is, hundreds, actually thousands of these bodies have been detected. A new asteroid belt is out there. We call it the Kuiper belt or Kuiper belt. He was a famous astronomer, and he worked at Yerkes Observatory for a number of years. Some of these turn out to be larger than Pluto. So this became a situation like when the asteroids were being first discovered. Astronomers decided these things aren't really planets. First of all, Pluto has an orbit that's not normal for a planet. It has a size that's not normal for a planet, and there's hundreds of bodies that are similar to it. So, is it a planet? Well, astronomers did a little bit of politics, as I call it. Just like for asteroids, they said, we really have a new type of object, something they now called dwarf planets. A dwarf planet is something that's in hydrostatic equilibrium. That's a technical term, which means they have enough gravity that they're round. And they don't have enough gravity to clear their neighborhood. Big planets like Jupiter have enough gravity that if a small body gets near it, it either becomes a moon of Jupiter or Jupiter ejects it from that part of the solar system. So it has to have a certain amount of gravity, enough, but not too much. to make it a dwarf planet. So a dwarf means a small planet. And there are 5 dwarf planets that have been accepted for sure. There's lots of other candidates, but these bodies are distant and it's very hard. There's Pluto. There's Ceres, that was one of their first original asteroid, which is round and has enough gravity to bring it that way, but not enough to clear its neighborhood. It's in with a bunch of other asteroids. And then these are things in that Kuiper belt that are big enough to be called dwarf planets. They have enough gravity that they can form their shape into a round shape. This Eris is actually bigger than Pluto, the one that you see here. Makemake and Haumea. These are what we now recognize for sure as dwarf planets, our new category that's been set up by the astronomers for the definition. A complicated chart. The first column gives the name of the object. We have the gas planets, we have the Earth-like planets, and then we have these dwarf planets. And I think you can see here's the diameter in terms of the Earth. So this is 11 times bigger than the Earth in diameter. The Earth, of course, is 1 Earth diameter. And these down here are about 20% or larger. So they're much smaller. This is the mass or the amount of material they have. Jupiter 317 times, even the smallest one is 15 times more than the Earth. Mercury is the smallest. It has only about 5% of the Earth, but these have fraction of a percent, about 20 times less than Mercury. This figure basically indicates how strong the gravity is. You can see here that it drops from Jupiter with tremendous gravity down to a small number, 942, but these things are 0.0021 or 0.2% of what you might consider to be the boundary line between these rocky planets and the dwarf planets, which are mostly icy bodies. Number of moons, these tend to have a lot of gravity. They get a lot of moons. These have enough gravity in some cases to capture moons, but not very many. And these actually have enough gravity to capture moons because they're not enough gravity that it would eject things that come into their system. So there's bodies around that can actually get captured by these dwarf planets. So is Pluto a planet? Well, it depends on your definition of a planet. It's not like the traditional planets. So astronomers played politics here. They made up a name for a new type of object that sort of says Pluto is a planet. It's a dwarf planet. And that makes people happy because they said, oh, Pluto is a planet. Yes, but it's a dwarf planet. They can always qualify that. So that is the answer to, is Pluto a planet or not? Yes, it's a planet, but it's a special type of planet called a dwarf planet. There was in 2015, there's a spacecraft called New Horizons that flew by Pluto. There's a picture of it. I think you can see a big ice cap on the surface of the planet. The New Horizons mission was very interesting historically too. It's the only spacecraft to visit Pluto. So it really provided all of the information we have about this, other than a little bit about its orbit. The astronomer that managed to get the spacecraft launched was named Alan Stern. He had an idea in 1989 that Pluto should be visited by a spacecraft. So he started an organization called the Pluto Underground, and they began telling NASA, boy, we ought to send a spacecraft out there. In 1990, they told him, nope, too expensive, too hard to do. 1992, nope, not going to do it. He asked him again, 1995, no, we're not going to do it. He kept asking about every 2 or 3 years, he'd put in a request. And of course, to put in a request, you had to put a lot of information in about what science could be done and who would be involved in it. Finally, in 2003, they approved it. It took them 3 years to build and launch the spacecraft. It arrived at Pluto in 2015. So 3 years to build it and then being launched. And then it took another 9 years, 9.5 years before it arrived at Pluto. At that distance in our solar system, the radio signals travel at the speed of light, and that meant the communication time was about 5 hours. That makes it difficult for the space mission to operate, because if you see that you want to make a slight adjustment, it takes 5 hours before the spacecraft will take your signal and then change its orbit, say slightly, or change the position of the camera. And then it's 5 more hours before you find out if it actually worked. So pretty difficult, pretty sophisticated mission. Here's some Pluto facts. Pluto takes 248 years to circle the sun. It's only gone about 1/3 of the way around its orbit since its discovery. The orbit has 120-degree axial tilt, which take 90 degrees out of that. That's about a 20-degree. It sort of goes backwards compared to some of the other planets. The surface is 98% nitrogen ice. It's ice, but it's nitrogen gas ice, not the water ice. There is water on Pluto, but not too much. The surface temperature is about minus 229 Celsius or minus 444 degrees Fahrenheit. It doesn't change very much. It's a pretty cold place. It does have a thin atmosphere, so it has a blue sky, but its atmosphere is methane gas, not nitrogen and oxygen as we have. The interior is probably differentiated. Again, it's a technical term, which means that there's probably an inner shell of Pluto, which is rocky material. Over that, you have a frozen ocean of water ice. And then above that, you have nitrogen ice. So you sort of have a three body planet put together. That is what the gravity seems to indicate, that there are differences inside in the theoretical calculations. Nobody really knows, of course. You'd really have to land on the planet and explore it to find out if that's the case. So we have finished our tour. I think we can go back now, if I can go back to the picture here and see if there are any questions from anywhere, or if we just leave it at that. Michelle, back to you.
I think we're good on questions, but I found that fascinating. I didn't even know there were dwarf planets. Time for me to take up astronomy for sure.
All
So
right. And that's it. You will get this as a librarian. Why is Pluto not a planet? My parents told me there were 9 planets and now there's only 8. What happened?
that's right. That's right. I remember when that happened.
Mhm.
Lots of discussion.
And
So, Ozzie, thank you. It was really interesting. And the gases, and I think the thing I found really interesting was Mars. I forget how you said it, but it would either absorb the matter around it or shoot it away. You had a
right,
better
the
way of
gravity, the gravity is such, it's strong gravity, as we know on the Earth. Gravity keeps us on the Earth. But if a small body, like an asteroid, were to get close to the Earth, what it would do is change its orbit. And if it got close enough, it might actually become a small moon of us. So it clears out most of the bodies that approach the Earth with such a speed. The gravity speeds them up and it shoots them off into another orbit. Whereas the asteroids don't have enough gravity, so the asteroids all sort of move along together without really affecting each other too much. They do a little bit, but not very much. But the planets, they do. They have a tremendous effect. So often you'll have a comet that comes into the solar system. If it passes Jupiter, its orbit will be completely switched. And it may take it so that it comes very close to the Earth, for example. Some of the most spectacular comets have been affected by Jupiter's gravity such that they bring the comet very close to the Earth.
It was very cool. That and that Pluto had been discovered 200 years ago by another famous astronomer, Galileo, at the time, but it took people all that time to catch up that he had already discovered it.
Yeah, not Pluto, Neptune.
Oh, Neptune,
Yeah,
Neptune.
Neptune. And he had it in his logbook, which was interesting.
Yeah.
He kept records, and then the historians could go back and say, oh, well, gosh, here, look what he saw. He saw this thing, just like we found on the old photographs that I showed you. So
Yeah.
then, well, let's go see if we have a photograph. And when they started looking and comparing all of those stars, lots of stars there, they went through and looked at almost all those stars and they found one that had moved. Now
Super
it's
cool.
Pluto.
Well, thank you, Ozzie. we all appreciated your vast knowledge and sharing it with us tonight. And if anyone has any questions when we launch this in Facebook, Ozzie can answer them throughout the week. And next week is our last February STAR program with Roland Miller, an aerospace photographer. He'll be sharing pictures taken of the space shuttle and his collaboration with an Italian astronaut
Restaurant. Yeah.
featuring the space station. So thank you, everyone, and good night.
Good night.